Good morning, my name is Serena Sorrentino. My tutor is Professor Sonia Bergamaschi, and the title of my presentation is Schema Normalization and Probabilistic Lexical Annotation for Improving Schema Matching. We will start by describing the problem addressed during my last year of PhD. And we define the problem of schema matching, that is the problem of finding relationship among heterogeneous data sources, heterogeneous structure, and semantics. Starting from the hidden meaning associated to schema elements, we can discover lexical relationship across heterogeneous data sources. To do that, a method for lexical annotation is needed. Lexical annotation, in simple words, can be defined as the explicit inclusion of the meaning of a data source element with respect to a lexical knowledge, that in our case is the well-known lexical database WordNet. Manual lexical annotation is a boring and time-consuming task. Then a method for automatic or semi-automatic lexical annotation is mandatory to perform schema matching, in particular schema matching on the fly. However, to do that, we have to deal with two main problems. The first is that schemas may contain several non-dictionary words. What is a non-dictionary word? It's a word that doesn't have an entry in the lexical resource and may be, for example, a compound noun or an acronym or an abbreviation. Moreover, automatic or semi-automatic lexical annotation is intrinsically uncertain. Then we need to enrich the concept of lexical annotation by adding the notion of uncertainty. To deal with the problem of non-dictionary works, I have developed, together with, in collaboration with the PhD student Maciej Gawinecki, a method for schema normalization. Schema normalization is the reduction of each label to some standardized form that can be easily recognized by the designer. But in our case, with schema normalization, we mean the process of abbreviations expansion and compound nouns interpretation. To give an idea of the problem, this picture shows a simple example where we have two schemas that need to be integrated, and PO and purchase order. And without schema normalization, we discover several lexical relationships among schema elements. In particular, we discover also a false positive lexical synonym relationship between the compound noun customer name and the compound noun client address, as the term customer is a synonym of the term client, but the whole meaning of the schema element customer name is not a synonym of the whole meaning of the compound noun client address. Moreover, without schema normalization, we are not able to discover in automatic way that exists also a synonym relationship between the schema element amount and the schema element QTY, that is an abbreviation for the term quantity. By using schema normalization, we will be able to discover only the right lexical relationship. Schema normalization can be divided in three main steps. The first one is the selection of the label to be normalized. The second one is automatic abbreviation expansion. And the last one is compound noun annotation. What is a compound noun? In simple words, is a word composed by two or more words that are called compound noun constituents. And to perform automatic or semi-automatic compound noun notation, a method for their interpretation is needed. With compound noun interpretation, we mean the process of finding the right semantics relationship among their constituents. Now, let's move to the second problem, that is uncertainty in lexical annotation. And uncertainty in lexical annotation is represented as a probability, where probability is used to measure the imprecision during lexical annotation process. I have taken part to the development of a method called PWSD, Probabilistic Word Sense Disambiguation Method. And PWSD is able to annotate each schema element with one or more WordNet meanings and moreover to assign to each of these annotation a probability value that represents the reliability of the annotation itself. PWSD is based on a combination of several word-sense disambiguation algorithms, and all these algorithms need to be previously evaluated in order to determine their reliability. At the end, all the results of the word-sense disambiguation algorithms are combined by using the Dempsey-Schaffer theory of combination. All these probabilistic annotation then are used to derive probabilistic lexical relationship, which are collected in a component called probabilistic common thesaurus. Both schema normalization and probabilistic lexical annotation have been implemented within the MOMIS system. MOMIS is a framework for the integration of structured and semi-structured data sources. In MOMIS, the process of relationship discovery is composed by three main steps. The first phase is the source schemas extraction. During this phase, the schemas of sources are automatically extracted and translated in a common language. Then these schemas represent the input of the second phase, lexical knowledge extraction, and during this phase we perform schema normalization and then probabilistic word-sense disambiguation. At the end, starting by the probabilistic annotation, we are able to derive probabilistic lexical relationship, which are collected together with structural and inferred relationship in the MOMIS component probabilistic common thesaurus. We have evaluated the performance of PWSD and the lexical and the schema normalization process during the lexical annotation within the MOMIS system. We evaluate on two real-world data set, and in particular, by using PWSD associated with schema normalization, we are able to increase and improve significantly both precision and recall. To sum up, I have presented a method for schema normalization and a method for probabilistic word-sense disambiguation. Both these methods have been implemented within MOMIS, and experimental results have shown as by using these methods it is possible to improve significantly the result of the lexical relationship discovery process. Future work will be devoted on the study of another kind of non-dictionary words, in particular words that are not present in the lexical resource as they belong to a very specific application domain, for example, medicine, architecture, and so on. These are my publications, and thank you for your attention.